All right, guys, here we go again. This time we're on section 1.5, which is complex numbers. A complex number is written in the form A plus BI, where A is a real number and B is imaginary. B cannot equal 0 if it is a complex number. Now, a real number will be written as B equals 0. But then when you have imaginary numbers, okay, B cannot equal 0. When when this number here, A, is equal to 0, it's a pure imaginary number. And if you think about it, okay, 0 plus 5i. This is A, this is B. If A is 0, then it's just 5i. That's why it is called a pure imaginary number. Okay, then you have A plus BI and C plus DI are equal if and only if A has to be equal to C, so this has to be equal to this, and B has to be equal to D. So this has to be equal to this. If that is the case, then they are equal. Then you have what are called complex conjugates. And a complex conjugate says that if you have A plus BI, its conjugate is A minus BI. And that's very important. We're going to use that later to get rid of things. Okay? So, the next thing we're going to look at, and really pay attention to this. If you just have I, that's equal to I. Now, most of you know that I squared is equal to -1. But you never really pay attention to I cubed. I cubed is the same as I times I squared, which is I times -1, which is -I. Then I to the 4th is equal to I squared, that's an I, not a T, I squared times I squared, which will give me -1 times -1, which is +1. Okay, those are pretty important. But here's where it gets fun. Let's say they tell you to find the value of I to the 56th, I to the 57th, I to the 58th and I to the 59th. You have to find all those. It looks difficult. You're going, oh my God, this sucks. It is so easy. It is disgusting. This right here is the same as I to the 0, right? No, wrong. It's I to the 1. Okay? So what we do is we take this, 56, and we divide it by 4. That'll give me 1, 4, 16. It's 14. There's no remainder. So that means this is the same as this. So that is 1. Okay? I to the 57th will do the same thing. 57 divided by 4. 1, 4, 17. That's 4 with a remainder of 1. Right here, see this exponent of 1? That matches the remainder. So this is I. 58. We do it again. Divide it by 4. 1, 4, 18, 4, 16. Remainder 2. Well, the remainder is 2 right here. So it's -1. The last one, take 59. 1, 4, 19 is 4, 16, which is 3, remainder of 3. Right there, -I. So all you do is you divide whatever the exponent is, right here, by 4. Whatever your remainder is, let's say on this one we had a remainder of 0. So it matches up with this right here. That means 4 goes into it evenly. So it's always 1. If you have a remainder of 1, it always matches up with this. So it's I. And therefore, remainder of 2, you're here, -1. And remainder 3, you're here, -I. So now let's do some examples. I have the square root of -4 plus the square root of -16 plus the square root of -1. Well, the square root of -4 is just 2i. Plus the square root of 16, 4i. Plus the square root of -1 is I. So I have 2i plus 4i is 6i, plus another I is just 7i. There's my answer. Now, if I have 4 minus 3i plus -6 plus 8i, all I do is I go back and I add the whole numbers, the a's. 4 plus -6 is -2. -3 plus 8 is positive 5i. There's my answer. Okay? If I have 6 plus I times 6 minus I got to do what? Double distribute. So I go here. 6 times 6 is 36, minus 6i, plus 6i, minus I squared. Well, these cancel, and I have 36 minus I squared, which is -1. 36 minus -1 is 37. Now, do you notice that those were conjugates? When you multiply two conjugates with complex numbers, then the imaginary part disappears. It's much the same as with a radical. Okay? So let's look at another one. 8 plus 3i times 2 minus 5i. Not -2, gosh darn it. Two minus 5i. Well, now I'm going to multiply here, say 16 minus 40i plus 6i minus 15i squared. Well, that's 16. -40 plus 6 is minus 34i minus 15 times -1, which is 16. So 16 plus 16 is 32 minus 34i. Now I'm going to have 1 over 2 plus 5i. Here's the problem. Much like a radical, I cannot have an imaginary in the bottom. Can't happen. It's against the law. This is an I. Sorry, I didn't draw it very good. So, to get rid of that on bottom, I have to multiply both the top and bottom by its conjugate. So I go 2 minus 5i. 2 minus 5i. Well, when I multiply the top, that's just 2 minus 5i. Gosh darn, I'm having a rough time today. Okay, so now the bottom, I'm going to multiply here, get 4 minus 10i plus 10i minus 25i squared. These cancel. On top, I have 2 minus 5i. On bottom now, I have 4 minus 25 times -1, which is plus 25. So my answer is 2 minus 5i all over 29. And there you go. The next one. We're going to have 5 plus I over 5 minus I. Well, I have to get rid of that bottom. To do that, I got to multiply by the conjugate. 5 plus I. 5 plus I. Well, now I have to double distribute on both. 25 plus 5I plus 5I plus I squared, all over 25 plus 5I minus 5I minus I squared. Well, on top, I got 25 plus 10I minus 1. All over, these cancel, 25 minus 1. So I put those together, I got 24 plus 10I over 24. Oh, wait. How did I screw this up? Minus a minus is a plus. That should be 26. Oh, Lord. Everybody see what I messed up on? I said minus I squared was minus 1. That should be minus a minus 1, which is a plus 1, so that's 26. Now I can divide everything here by 2. So I divide it all by 2. That would be 12 plus 5i all over 13. And there is my answer. Okay, we're going to do one more problem here, which is just 5 over I. Well, to get rid of the I, just multiply the top and bottom both by I, because I times I is I squared, right? So that's going to give me 5i over I squared, which is just 5i over negative 1, which is just negative 5i. And that's all I have to do. I hope you got through that. I hope you understand it. And I will be answering questions when we meet next time. Thank you.